Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into another great topic, solving linear equations and word problems. Now, if you're new to my channel, I put timecodes in for this video in the description box below. So use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I've been linking my 9th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have one example. So leave a like, hit the notification bell, smash the subscribe button, and let's get started. So today we're going to solve a linear equation found within our word problem. However, before we can solve it, we need to first identify it. And in order to do that, we're going to need to do three things. One thing we're going to need to do is remember our general form for our linear equation. So A equals AX plus B. Some A, some B, and you have your two variables. So that's the first thing you're going to need. The second thing is find your cap. Your cap is going to be in here somewhere, what I call your cap, and you need to be able to extract it. The third thing and the last thing is find your change. That's also going to be within this word problem that you're going to need to extract. Now, you might be asking, what is the cap and what's the change? Well, your cap is going to be your dependent variable, and your change is going to be your independent variable. If you have all of these things, if you remember what your general form for your linear equation looks like, if you can find your cap and your change, you can put all of it together and you can create the linear equation that's in this word problem. Once you have it, you then solve it. Now, why do I use the terms cap and change? Well, dependent and independent variable may be hard to kind of grasp sometimes, and cap and change kind of makes sense to me because, especially when we're dealing with word problems like this, cap kind of sells what I'm actually looking for probably a little bit more to me than dependent variable. And that's because when you have, let's say, some general AX plus B, let's say we have, just make it super easy, Y equals X plus 1. We are told that this is going to be our independent variable because we control this. We throw a bunch of variable values in here and we're going to get something from Y. Y is going to be changing, X is going to be changing, but Y's changes depend on what you put in for X. So if you put in 1, you're going to get 2. If you put in 2, you're going to get 3, and so forth. So both of them are changing. However, when you're doing your word problems and you're trying to solve your linear equation, you're actually not necessarily having both things change. They're pretty fixed. In fact, you have a set Y and you're trying to find the correct X value that works. So we're capping our Y or fixing our Y at a particular value, and although we don't necessarily know the X and that can change, there's only going to be one X that works. So this is capped at something, which will then allow us to determine, as we have different X's that we can put in, which one works best. So I say cap because we're capping the Y, and we're going to keep changing our X until we find the correct X that works for this equation. Hence, cap and change. But if that confuses you, find your dependent variable and find your independent variable. So now that we know what we're looking for, we have our general form, we're looking for our cap, we're looking for our change. Let's read the word problem we have and see if we can identify some things. So it says you have $16 and a coupon for a $5 discount at a local supermarket. A bottle of olive oil costs $7. How many bottles can you buy? Pretty straightforward. I didn't want to pick something overly complicated just to show you how to do this. But there's three things that you should have picked up on. I'll circle them. There's $16 there. There's a coupon for a $5 discount. And you know that your bottle of olive oil costs $7. Now, you can circle that too. That's tied to that, but it's on 2 different lines, so couldn't cover all of that. But you have 3 things, so this is going to be 1, 2, and both of these will be 3 because it's tied together. There's 3 things that are in this word problem that we have to figure out where they belong. Once again, we're starting with our general form, y equals ax plus b, and we're trying to find our dependent variable and independent variable, or your cap and your change. Let's start with our cap. Are we capped anywhere? If you're looking at this, are we capped? Is there anything fixing us? When we have $16, there's a coupon for $5, and each bottle of olive oil costs $7. Is there a cap? The cap is going to depend on what we're trying to do in this word problem. It seems like we're trying to buy something, right? So we're going to a store, the local supermarket, and we're trying to buy something. What we're trying to buy is not important, but the fact that we're trying to buy something lets you know that you're going to be capped by what your discount is. Probably not. You're going to be capped by how much money you're bringing to the store? Probably yes. If you're trying to buy things, you can't buy more than what you have money to buy with, right? If you go to the store and you only have $1, you're capped at $1 of what you can buy. If you have $10, you're capped at 10. If you have $100, you're capped at $100. So if you're going to the store to buy something and until you have $16, that's your cap. You can't go any higher than that. So we found our cap, which is our dependent variable, which in this case is our y. So we know our y to be 16. Now we're trying to find our change, our dependent variable. We already know that 16 is spoken for. So we have coupon for $5 and we have a bottle of olive oil. Which one's going to be changing? So if you go to the store and you have this discount of $5, is that going to then suddenly change to a discount of $10? No. Coupon is not necessarily changing. So the only other thing here is going to be this bottle of olive oil. Now the bottle doesn't change either though. So how is that going to work? None of these are changing. Once again, what are you trying to do? Are you trying to acquire more coupons or discounts? Or are you trying to buy olive oil? You're trying to buy bottles of olive oil. So although the price is not changing, the number of coupons aren't changing, the number of bottles does change. And each bottle is going to cost $7. So you know that your X is actually going to be bottles of olive oil. However, when you're trying to put all this together, now we know that we're going to have 16 equals, we have some A, we have our bottles of olive oil, which is going to be X, right? Plus some B. We have this. What is A? If X is going to be our bottles of olive oil, what is A? That's going to be the cost of each bottle. So we know A to be 7. This is why you don't necessarily have to worry about your A's and B's. They will fall into place naturally if you can find your dependent variable and your independent variable, or your cap and your change. Now we have this B here. Do we have a B? Is there something that should go here? Well, there's only one thing left, but don't let that necessarily get you, because sometimes you have more information in your word problem than necessary. So be very strategic about what you're putting into your linear equation. This is a discount. Is this discount going to affect how many bottles of olive oil we can buy? Yes. It's going to have an impact on our linear equation, so it does belong in our equation. And it says it's a discount for $5. So we know it's $5, but are we adding to this price? Because the sign matters. It's a discount. So it's going to make it cheaper by $5. However much the price of all of them is going to be, we're going to subtract that from, we're going to subtract 5 from that total amount. So this is how our equation ends up looking. Now that we've determined our equation, we can easily solve this by trying to get X by itself. So if we start here, remember when we solve our linear equations, we want to isolate our variable. There's only one variable here. We're trying to find the appropriate variable, the appropriate value for this variable. So we want to isolate it. So we have to add 5 to both sides, right? And by doing that, we're going to have 21 equals 7x. These cancel out. And then we're going to divide both sides by 7. And by doing that, we're going to get x equals 3. And I always tell you this, if you have time, check your work. So let's plug x back into our original equation. Remember, that was 7x plus 5 equals 16. Let's fix that plus. 7x plus 5, minus 5. Minus 5 equals 16. If we were to plug that 3 into that x, do we get 16? 21 minus 5, 16 equals 16. Good. That means our x equals 3 is correct. So before you can even solve your equation, you first have to create it, find it, pull it out of your word problem. Remember your general form. You're going to start plugging things into this general form. Find your cap, find your change. But you have to understand what's happening inside your word problem, because that's going to determine what your cap and change are going to be. Once you have all that, plug in what's necessary. There will be times when your word problem will give you way more than you need. Don't try to use everything all the time if it doesn't make sense to do it. That discount is going to have an effect on our total price, so we had to put it in there. After you create it, solve it. So I hope you were able to follow along with today's video, and I hope you now know not just how to solve your linear equations within word problems, but how to find your linear equations within your word problems. However, if you have any questions about what you saw today, or even your own homework, feel free to put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, hit that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Now, that's all the time I have for today. I really hope this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.